Welcome to Engineering Scale Models. I'm Jason, and I do models. Today is going to be, I believe, part 3 in our Arduino series on hooking up some electronics to your scale modelings. And as if you watch the other videos, you know that I am doing a traffic light simulation with a bunch of features, controllable cycle time, and all kinds of good stuff. And in the process of designing that, I actually have a semi-working model. It still needs coding work, but I have it set up here, and I have the lights. You can plug it in like so, and the lights will light up. You see when this side is green, that's red, and then it'll run through a cycle. And then to an extent, I can use this potentiometer to adjust the cycle time to make the green slower or longer in the cycle. I'm working on the most optimized code to do this, but in order to do this function, I need to use what is called a software interrupt to constantly read the value on this potentiometer so it can adjust the cycle in real time. And I'm going to show you what I'm talking about on the whiteboard. So we have the whiteboard here, and what am I talking about? So I have my setup and pin declarations is fine, but I have my loop here. Here's my void loop, and the first thing I'm going to do is I'm going to turn on LED. Turn on LED, and then I'm going to wait for 10 seconds. Well, that 10 seconds is a variable that I can control with the potentiometer. So as I turn the potentiometer up and down, it'll go from, say, 1 second all the way to 10 seconds. But if I read the potentiometer up here, if I read pot here, it'll read it and then it'll do whatever delay I put in. But then if I change it in the middle of this 10 seconds, it won't change, because it won't read the potentiometer again until it goes through the loop and back up to read potentiometer. So you can see where this comes into play. If I turn on another LED in the loop and I do a wait time, and then I continue that on, and I do 6, 7, 8 LEDs, and I have a program that with all the wait times that take a minute or 2 minutes to run, it's only going to read that potentiometer value one time at the beginning of the loop. So in order to make adjustments, I have to wait for it to go through the whole loop. So what do I need? I need a software interrupt. And what does a software interrupt do? Let me get this out of here. Software interrupt is a special program. It uses the timer 1 library. So you'd have to do pound include, and you put the timer 1 library in. Oh, it's .h. Let me put that in correctly. .h, and you put that at the top of your program, no semicolon, and then you may have to download the library. I will show you how that is done, but this basically gives you a software interrupt, and what you do is you will set up your timer 1. So you're going to set it up and tell it how many microseconds, however many microseconds you want it to check for that, to do that interrupt and check whatever function you want to check. So say I want it to check every second, so 1 second in microseconds is 100,000 microseconds. So I normally don't. I normally have it check like every 10 milliseconds. So I do like 10,000. If I wanted 10 milliseconds, it would be 10,000. 10,000 micro. So you're going to do that in the setup, and I'm going to walk you all through that. And then you need to attach the interrupt. So you need to attach it, and then what you attach it to, it's going to call a function. And that function it calls is going to be below the void loop. Below void loop. So after that last curly bracket. So after that last curly bracket, you're going to put, and you're going to label that, function void and the name of the function. You can name it interrupt or whatever you want to name the function. So let's take a look of how the code is written. I'm going to show you a very simple code, and then I'm going to show you how I use it in the traffic light program. Just that part of the program, because the whole program is not fleshed out, and then you can get a sense of it. The traffic light program has a lot more code I haven't taught you guys yet, but I will go through this and I'll show you how to put in an interrupt. So let us go to this monitor here. Okay, so this is the program we did on the potentiometers. We have a potentiometer pen. Let me see if I can do this with the camera. Yeah, so we have our prototyping board on here. And let's zoom in. And we have our potentiometer hooked up to where we can control the value of this LED. And we can make it go bright or dim with the LED. And what it's doing is reading the value of the LED, and then it's printing that value to the LED. So here it is right here. It is reading the pot value from the pot pin, which is the LED. Then it's going to print what the value is, and I can open the serial monitor to show you. Okay, of course, it's not okay. We're going to deal with that later. But it would print it, and then the map value is going to map the pot value according to the 255 that needs to be outputted to the thing, and then it's going to write to the LED the map value, and then it's going to delay for 250 milliseconds. Well, if I come in here first, let me get my serial monitor to work here. Let me upload this code to the Arduino. Of course. This computer switches my COM ports between 3 and 5 every time I hook up an Arduino. It is crazy. So that's uploaded. Let us open the serial monitor here and make it a little bit bigger. Okay, actually, I'm going to put the serial monitor down here. I'm going to give you a different view. Okay, so there's the serial monitor there. Let's see here if I can make... Okay, so let's just increase the font size here. For some reason Control Plus wasn't working. Okay. But you still can't see it that well. Alright, I'm going to have to go back to a view with the pad and the monitor. So that is a little bit bigger and a little easier to read. Probably could do it again. Okay, that's a little better and easier to read. Now let me see if we come down here and drag the serial monitor back up here. Okay, so there we go. We can see this. Now you see that every quarter a second, it's reading the value, it's mapping the value, and it is printing the value of the map value, and then it's writing to the LED, and it changes in pretty much real time with the turning of it, because it only has a quarter second delay. Now if I come up here and I add a, let's just do a 5-second delay. I do a 5-second delay. There we go. I do a 5-second delay on there and I upload this code. Let's upload this. And let's get the serial monitor. So now it's only giving me a value every 5 seconds. So, and now if I change it, see, I made a huge sweep, and now 5 seconds later it tells me what I did. So I have to turn it, wait, turn it, wait, turn it, wait, turn it, wait, turn it, wait. So it's not getting updated all the time. So what you can do is you can put this reading of the potentiometer in a software interrupt, and it will constantly read the value of the potentiometer, and then the program will use it as it lights up or cycles through something multiple different ways. Now let me show you how to do a software interrupt. Let's pull up this code here. Not that one, this one. This one works better. So this is better to read. So we're going to come up here, and you see I did the hashtag include timer1.h. Now you get that from going to sketch, include library, and then you scroll through your included libraries here to see if you have timer1. If you do not have timer1, you go over to tools, manage libraries, click on that, and then you can come in here into this. It's going to take a minute to load, and you come into the search box and you type in TIMER1 and you hit search, and it gives me 2. I need timer1 because that's the name of it, and then it would tell you you can install it. I already have installed it. So that's how you can get libraries. You can search libraries the different ways on here. There are many different ways to get libraries. I find that this is the easiest way to get a library, unless it's one that's only available on GitHub, and then I don't like to use stuff like that. So that is how you get the library, and then you can go and you can include your library. You can type it in, or you can go to add include library. Like, say I wanted to just include, and I'll get rid of it, I just wanted to include the keypad library. See how I just clicked on it and it included it in there for me? So I'm just going to take that out. Just going to take that out. Get back up to the top. So that's my timer1 library. Now, I need a... Now, for the programs that are running in the interrupt, you need to make the integers in the variables it's changing volatile. So the Arduino knows at any time this integer can change without notice in the loop program. So I am gathering 2 values inside the function, pot value, and then I'm converting it to a CT time 1. So I labeled both of these volatile integers. So, and I default set it to 5,000 for troubleshooting purposes. And then now I come down here to the void setup, and this is where I need to set up the interrupt. I have it right here. And you do timer 1 initialize, and then you're going to do your interrupt time, and that's in milliseconds. So I come up here, and my int time is, I'm doing it every, or microseconds. I'm doing 1,000 microseconds, so I'm doing it every millisecond. It is interrupting the program to check the value of the potentiometer. And because that's all I'm doing, I'm not really doing a lot. So, you know, I could change that to another 0 in there, and I shouldn't have any issues. So that's my interrupt time. And then you need timer 1 attach interrupt, and then you need to put the name of the function that you are going to call every time it interrupts. So every 10 milliseconds, it's going to interrupt and run cycle time. This is what it's going to do every time. Every time 10 milliseconds goes by, or a second, whatever you set your interrupt time for, whatever you set that for, it's going to interrupt and run this program here. So that program down there is after the void loop. So I have my void loop, and then this is where my functions start right here. So this was the end of my void loop. See, this is the end of the void loop. So this is all my functions. And the first function I put in is the interrupt function, and it's called cycle time. It starts with a void, has its function name, then it would have its conditional or parameters. There is none. Then an open curly bracket. What it's going to do, it's going to assign pot value and analog read off of the pot pin, and then it is going to set C time 1 to the map value of pot value, and then from 1023, in this case 5 seconds to 10 seconds of cycle time in the traffic light system. And then again, there's other functions, but don't worry about that. I will show you that these programs run with a delay time of C timer 1, so they're always being updated. So as I adjust the potentiometer on the traffic light system, this C time will always change. So the time it goes to the next C time in this function, it will adjust, it'll already be adjusted. And I have another method of doing this where I adjust it differently that I'll show in a future thing. But I mainly wanted to discuss how an interrupt works. So that is how a software interrupt works. I will show it in more detail. I guess I can hook it up and show you guys how it works. Let me go to, let's go to this one here. And I will go back here. So I hooked up the Arduino, I got my potentiometer going, and I will check my COM port just to make sure. Yeah, it's on COM 3 now. So I will upload this code, error compiling, of course. So, okay. It is an Arduino. No, it is on COM port 3. Error compile. Does it just compile? This so worked earlier. What is this coded message? File specified. Does this one work? Now, I don't know what this error I'm getting is. It has to do with the timer 1 library, I think. let's go to this one. Let's go to save as version 2. I like to save them as different versions as I make changes. Let's try that. It's still giving me the same error. I get occasional errors on here. If it doesn't work, I'm going to stop here and refigure it out, and yeah, so it's still not working. Is it just not like that board? Yeah, it's actually giving me a compiling error here, and I don't know why. Tools. Let me get rid of this one and try that. Now, so I'm going to stop here and figure out what. It doesn't even show me what the error is. It just says error compiling on board. That is so weird. Can I make this bigger? Okay, so it says something. Cannot find a file specified. But does this program work that I just ran and showed you guys? Yeah, so that compiles. So I'll figure out what's wrong on the other one. Let me just see here. Let me just include the timer library and see if that's the issue with the timer one. No, that's not what the issue was. So it's not a timer one issue. It has to do with something. Yeah, that's weird. Yeah, that's gonna glitch out. Let's close this out. Okay, let's see, what is this? This should be version 22. I like to do these errors in real time so you guys have the same problem. You know the steps to take to fix the issue. Yeah, it doesn't even want to start the program. There it goes. Okay, now does it give me a compiling error? No, it doesn't. So that was the issue. No, now I got an error here. Oh, the stupid COM port. COM 5 now. Yay. So if I believe I have the serial monitor working on this, doing something. So the value is at 0 and the green cycle time is at a 5. Okay, well I had it hooked to the wrong Arduino, so I have to upload that again. Probably gonna have to have another. Oh, yep, now that one's on COM port 3. Okay, so that's just printed 5,000 seconds, and it's not reading that. I don't think that uploaded. Let's close that out. So if I change this, okay, why is it not? Okay, so there it goes. It's, well, because I'm running a bunch of cycles here. So it's waiting cycle time. So right now at 0, it's a 5-second millisecond delay for the green cycle. So, and then if I change it, it's at 7 seconds, and then I can change it all the way up. I believe that is going to be a 10-second green cycle, but it's got to go through one cycle. Well, in this case, both cycles, but I have a more updated program that will update in more real time. But is reading the value of the potentiometer in real time through the interrupt. I'm just not printing it out in real time because you don't want to print from an interrupt. But I can do some things, but I'm not a fan of how I did these functions with all the wait times and the functions. So I created a different version using some loops that get in and out and update more effectively. So that is that. So that's going to do it on software interrupts. I hope you guys grasp that. If you have any questions, leave me a comment down below, or you can email me at this email at the top there. You can also visit me on social media and leave a comment or a like there. You can subscribe to the channel. You could also pop over to Patreon for some schematics and things like that and supporting the channel. No need to sign up. There is some cool information there. But that's going to do it, guys. Thank you so much and have a fantastic day.